All right, thank you. Hello. One person. Hello. All right, there we go. So I'm Jason Aden on the core team. We're going to talk about packaging of Angular libraries. And to start this off, we are an ecosystem. We've got a lot of people here. We're all part of this Angular ecosystem. We've got a lot of people on live stream. A lot of people use Angular. And components are sort of the cornerstone of our ecosystem. And what we're trying to do with an Angular package format is establish a contract between the Angular team, library authors, and application developers. And if we all sort of conform to this contract, our applications should be able to consume libraries easily. We should be able to use the tools that we want to use and not have an issue. So this recommendation attempts to support the tools being used today. Who uses one of these? I'm sure many people use at least one, right? Probably multiples. So there's a lot of stuff out there, right? There's a lot of languages, there's a lot of transpilers, there's optimizers, module loaders, everything like that. So let's start with, what do application developers want out of a library? An application developer would like to be able to npm install your library and then import your components into his application module. And when he goes to build his application, the application developer would like, ideally, to be able to run ahead of time compilation and get an optimized bundle for their app that also supports tree shaking, right? So that kind of looks like this. We have our little UI library, and we import the button module and the forms module. And we create an app module with ng module that imports those two. So what if you had another 15 components in your UI library, right? We don't really want to distribute those to everybody that's consuming this application. So this format should help in achieving that goal. One of the things that we found surveying some of the libraries out there is that they don't all publish the necessary assets in order to support AOT compilation. So one of the necessary assets is type definitions. So taking a look at a library that might be published, these look like this. Who knows DTS files? Okay, most of us. So the DTS files are basically the type definitions that align with your JavaScript. And the other required asset that needs to be published is metadata files. Who has seen these before? Many fewer people, okay? So this was often the missing component in a lot of libraries that were being published, and these come from the Angular compiler. So how do we produce the required assets? Basically, the first requirement is that you use the Angular compiler. So you get it by npm installing @angular/compiler CLI, okay? In your node modules bin directory, you'll have an NGC command. And that's basically a drop-in replacement for the TypeScript compiler. It essentially wraps the TypeScript compiler, adding some additional options, adding additional output to support ahead-of-time compilation and to support building the ng factory files, ng style files. So a very simplified version of the NGC Angular compiler process. You've got your TypeScript source code. It runs through the Angular compiler. The Angular compiler delegates some of its work to the TypeScript compiler. And the result is compiled JavaScript code, metadata files, and DTS files. These are the required assets for libraries, okay? The Angular compiler also does produce ng factory files and ng style files. But you actually, as a library author, you don't want to publish those. Those are tied to the version of the compiler that you built them with, and they're an asset that the application should be publishing, not libraries, okay? So in order to produce those assets, we have to jump into a tsconfig file. TypeScript reads this tsconfig file, and the TypeScript compiler options live in a key called compiler options. And Angular's compiler reads from a custom key that was added called Angular compiler options. let's just look at a few of the required items that you should be using in the tsconfig file. So for your compiler options declaration, what this is going to do is this is going to tell TypeScript to generate the DTS files, to generate those type definitions. And you want to make sure to take those and publish those along with your library to NPM. The next key here that we recommend using is module ES2015. So when you're writing your TypeScript source, you're using import and export statements, right? And those are ES modules, right? Those are part of the ES module spec. So if you add this key to the tsconfig, then the compiled JavaScript will have import and export statements in it. It doesn't tell you whether or not your classes and your fat arrow functions are going to be transpiled down to ES5 or ES2015. The next key, target, here we're using ES5. This is going to tell TypeScript to take your classes and basically rewrite them in an ES5 format, right? So then let's look at the Angular compiler options. These are two of the minimum keys that we would recommend using. First, strict metadata omit. So what this does is it tells the Angular compiler to halt, throw an error, when the metadata files that it would be generating would cause an error in an application, okay? So you pretty much always want to turn this on. It's optional, but as an author, you should turn this on. You don't want to produce stuff that's just going to break. And skip template code gen. So what this does is it tells Angular compiler not to generate the ng factory files. It tells it not to generate the ng style files. It will only generate the pieces that are actually required for publishing your libraries. All right, let's take a look at this in action. Some of this I'm going to have to move pretty quick because we're going to roll through a decent amount. But what we're looking at here is a very small sample library. And in the root of our library, we have a package.json file. We have our dev dependencies. So as a library author, these are the dependencies that we're using. We're using Angular Core, compiler, CLI, and those rely on things like RxJS, TypeScript, and Zone. We also have a tsconfig file. This tsconfig file, in this particular example, is not used to build our library. This tsconfig file is only used for the editor environment. So in this case, VS Code. Let's look at the source of our library. At the root of the source, we have an export. There's only one component in this library, so we're re-exporting that component in an index file. I've also got another package.json file, right? And this also has a dependency of Angular Core, Rx, and Zone. But in this case, these are peer dependencies. Anybody ever written a peer dependency? Anybody ever seen when you npm install, if you npm install add Angular Core for the first time, it'll say peer dependency is not met because you didn't put Rx and Zone in there. So as a library, when you publish, you want to publish Angular and Rx and Zone as a peer dependency, meaning that the application developer is responsible for choosing the version of Angular that he or she wants to use. Then the other item of note in here is a key called module. So when you're producing your package.json file, the module key, the target of the module key, is basically where you can find the root of everything that you are publishing. And the word module specifically means that this file has import and export statements in it, okay? If it didn't, if it were in a different format like a UMD format or something else, you might see something like main, okay? Like main is supported by Node out of the box. Module is not necessarily supported by Node out of the box, but it is supported by tools like Webpack. So who uses Webpack for their apps? Like a lot of us, right? So Webpack will read the module key and use the value there. All right, and in our components, we have a really simple box component that just makes a little border. And we have an ng module that says that we are declaring the box component and we are exporting it into this class here, the box module. All right, so how do we build this? Everybody has a different opinion on how to actually build. What we're going to look at is what are the assets that we're actually going to end up publishing, what we're going to distribute. So we're going to start with a build file here. It's just a build.sh file. So I don't forget later, I'm going to put in here this. So we're going to clean up our previous build. And then we're going to get a handle on the Angular compiler, right? So node modules.bin /bin ngc. And all that we're going to do is run ngc, passing in a project. -p says what project you want to use. And we're going to pass in this tsconfig that we just took a look at. The only other thing that we're doing in our build file right now is copying this package.json file into the dist directory. So hopefully this works. All right, so now we have a dist. And this dist contains sort of the minimum items required in order to support application developers who want to AOT their code, who want to ahead of time compile their code. It's got index metadata file. It's got DTS files. Each file that exists in components has corresponding DTS files, corresponding metadata files. And the JavaScript is built using import and export statements. And our classes and decorators have been down-leveled to ES5. All right. So real quick summary on those things. We want to make sure that we are AOT ready. When we're publishing a library, we want to make sure that we are not stopping an application developer from AOTing their application. We have to publish DTS files, and we have to publish metadata files. All right, but it can get better than that. We can do some optimizations. These optimizations, the strategy is really around, the initial strategy is going to be around taking all of these separate JavaScript files and intelligently concatenating them into a single file. So the idea is we want to publish fewer ECMAScript modules in total. Currently, we suggest you use Rollup to do this. So Rollup is a tool that will start at the root of your library and follow all the import statements and take all the generated code and create a single file out of all that generated code. It'll rewrite all the import and export statements for you, and it does a pretty good job of this. And the result of running Rollup, we call a flat ECMAScript module. Igor coined the word FESM for it. So flattened ESM, okay? The other optimization that would be great if you can do is inlining templates and styles. So we don't currently have a great tool for doing this out of the box. If you look at a project like the Material 2, they've got a pass where they go through and they use a regex and they go and pluck files out and they inline all the templates and the CSS. It's a little bit cumbersome. Hopefully we can do something about that in the future, but if you can put the effort into the build process, it would be good to inline the templates and styles. And for a little bit more information on why we say you should do this roll-up, there's a great article called Cost of Small Modules, and it actually gives, there's a serious performance degradation as the number of modules that you are bundling into your application bundle. As that number increases, there's a serious performance degradation, and this article covers it pretty well. All right, one thing we now recommend you do not do is what we call a kitchen sink ng module. So who here has used Material 2? All right, so you import from at Angular/Material, right? And they are publishing or they were publishing an ng module called Angular Material. And essentially what it did was it was re-exporting all of the Angular Material components into a single ng module. The problem with that is that we want to avoid it because it completely breaks tree shaking. Down the road, as an app developer, if the only component you used was a tooltip, well, you don't want all of material or all of the library included in your final bundle. So these kitchen sink modules actually destroy the ability to do tree shaking. As a library developer, it kind of looks like this. You would say we have only two components or two modules in our library for box and highlight. Then a kitchen sink ng module would look like this. We would import them and directly re-export them. So this is do not use. All right. As a quick note on library organization, we're currently recommending an ng module per component. So rather than kitchen sink, just create one per component and export those from your library. What this allows us to do eventually is enable tree shaking, okay? So that all that code that's not actually used will be gone. Oh, I'm gonna run over. All right, so we import the box component, and we create an ng module that declares box and re-exports it as box module. All right, so let's take this little project here and go ahead and optimize it. So the optimizations that we want to do, we want to create a FESM, right, a flat ECMAScript module. And along with that, we want to have only a single metadata file, right? In the example we looked at a second ago, there's a metadata file for each DTS file and for each JavaScript file. But if we're rolling everything up into a single JavaScript file, we also want only a single metadata file. So the first thing that I'm going to do is change our target so that we're not building to dist, we're we're compiling to build. And then there is a couple of new options as of Angular 4 in Angular compiler options. So flat module out file. And I'm going to go ahead and name this simple UI lib.js. What this does is it says we are compiling the index.ts. And what the Angular compiler is going to do is it's going to take that and produce a file called simple UI lib that basically is the same as the index, but it will live alongside a flattened metadata file. We also need to give it a module identifier, so flat module ID. And we are just going to call this by the name that is in our package JSON, which is simple UI lib. All right, so if we run the build script, it won't work. All right, so what we need to do now is we need to run rollup. So I'm going to add rollup here. And rollup lives also in node modules bin. And after we run NGC, we are going to rollup build/simple UI lib.js, and we are going to pass it an out file. We're going to put this into dist/simple UI lib.js. All right. Should work now. All right, so there's a couple of warnings here. We can completely ignore them for now. They're only warnings. So now our dist folder doesn't have very much in it, but we see that we have a FESM, a flattened ECMAScript module. None of our source code actually imported both component and ng module in the same file, but Rollup's intelligent enough to rewrite our import statements and say, hey, somewhere in the code base, it required these two files. So it'll rewrite our imports for us. It does the same thing with the exports. And then the source code from all of our JavaScript files lives in this one file. Next thing we would need to do is copy from the build directory our metadata and DTS. Basically, we want everything that's not a JavaScript file. So we'll just run an rsync with an exclude star.js, and we want to grab everything in build that's not a JavaScript file and put it into dist. All right. Now we have all the DTS files that we need. They will live inside of components as well. Currently, there's no good way to flatten the DTS files. That may be coming from the TypeScript team, but for now, you're still going to have to publish DTS files in a large file graph. And we have the JavaScript file and the metadata file. So we now support AOT. All right. So real quick summary, we want to roll up into FESMs. We want to ideally inline our HTML and CSS into the distribution JavaScript. And we need to add these two keys to our, for NGC, we need to add these two keys to the tsconfig. All right, a couple advanced optimizations. I'll try to blitz through these. But the advanced optimizations, anybody here ever used Clojure Compiler? If you're at Google, put your hand down. Okay, actually that's like 5. That might be more than I thought there would be. It's great. So Clojure has a mode where it can do a really good job of packaging your files and getting rid of dead code, but it's heavily optimized for ES 2015 sources. Okay, so what we just built was ES 2015 modules with ES5 code. Okay, so part of our recommendation would be to publish ES 2015 as well. So we actually want to publish both. We want to publish FESMs with ES5 and FESMs with ES 2015. All right, so we'll really quickly optimize this thing. And the first thing that we can do is we come into our tsconfig build. There's an additional option for the Angular compiler, which is called annotate for Clojure compiler. And we'll set that to true. Everybody was here for Brad's talk this morning. He showed Clojure uses these JS-doc annotations, right, for method parameters and things like that. So what this will do is it will force NGC to output those JS-doc annotations for you. Let me just see if I have one in here. All right, so in order to actually see one of those, we're going to add a constructor. Public name string. This is a useless property, but the point is when we come into our JavaScript here, when box was transpiled, see we get this annotation on here. So by default, it will be essentially an any, but this does allow Clojure to take this and do its optimizations on your code. And there's some additional options you can do to actually make this like string, but we don't need to get into that. All right, and the next thing we need to do is build both ES 2015 and ES5, okay? So if we target ES 2015, everything's gonna work. Should work. And now our rolled up file has class keywords. It has fat arrow functions. It does not have decorators because they're not actually part of ES 2015. They're part of the next version. Okay? But we're not yet publishing in ES5. So what we're going to do is a pretty naive implementation here. You can feel free to do a better one for yourselves. But we're going to copy the tsconfig and call this one tsconfig ES5. And we're going to change the target back to ES5 for this one. And then in our build script, we're just going to run NGC twice. So the second time, we're going to run it over the ES5 tsconfig. And when we do our rollup, we're going to roll up into .es5.js. So the end result here should be that we have 2 files. They're essentially the same thing, but one has ES 2015 inside of it, and one has ES5. And the last thing we got to do is modify our package JSON. So this module key, by default, is used by Webpack. Webpack, by default, does not read ES 2016. Okay? So it reads modules, but it doesn't read ES2016. It will error when it hits the keyword class. Okay? So what we want to do is we want to change this to simple UI lib.es5.js. Okay, this makes it so that when an application developer pulls in your code and he's using Webpack, it will work out of the box. He doesn't need to add things like Babel or anything like that to it. We decided on a new key for package.json, which is just ES2015. So specifying the language level in the package.json, and that will point to a file that is in that particular format. All right. Hopefully this works. So now we get a dist, and we have 2 copies of our library. They won't be simultaneously used, so it's okay. ES5 looks just like it did at the very beginning, and ES2016 version has class and fat arrow functions. All right. So, quick summary on that. So we want to ship ES2015 code, also ship ES5 code. If for legacy reasons you need to ship UMD bundles, that's okay. You would add it to the main key of your package.json, but we're kind of trying to get away from that on the Angular team. It's not really necessary for most of the modern tools. Go ahead and enable annotate for closure compiler. This will help your code to be help people to be able to do the best optimizations possible. All right, and in summary on this format does support Webpack, Rollup, and lots of other tools. It supports AOT for application developers. It allows for tree shaking optimizations. We've got more on that coming. Support for closure compiler, and it optimizes for future tooling. A couple of links. We are publishing this as Angular package format 4. When Angular 5 comes out, there will be some adjustments, but version 4 will still work with Angular 5 on the packaging format. There's a seed project by Philippe Silva, link here. There's a demo, the demo that we went through, also linked. Alex Rauschmeier just wrote a really interesting article on packaging. He used what we did on the Angular project as the sample of how to do this correctly, which was quite interesting. And material 25 minutes ago published beta 3, and they have implemented this format. So give a hand to them. Thank you.